Hi, I'm Fiona Bell, a PhD candidate at the Atlas Institute at the University of Colorado Boulder. And today I'm going to discuss ReClaym Our Compost, biodegradable clay for intimate making. In this work, we want to explore what it means to develop and design with a new material that is both sustainable and personal. This motivated us to create ReClaym, an intimate clay-like biomaterial made from our composted food waste. We found decomposed food waste, known as compost, to be a compelling material to work with, given that it is inherently sustainable and unique to each person. Food waste revealing personal aspects such as food preferences, physical location, cultural identity, cooking techniques, and temporal relationships with food. Consequently, ReClaym mirrors our food waste, adopting different textures, colors, and smells based on the types of items we compost. To transform compost into ReClaym, we add sodium alginate, which is a brown seaweed extract, calcium carbonate, which is a common mineral, and water. When combined with water, the sodium alginate creates a gel, which we stabilized with the calcium carbonate. We mixed our gel into the compost to bind it together, creating a biomaterial that acts like clay and fully biodegrades when composted. To identify our optimal recipe for ReClaym, we experimented with a variety of ingredient ratios ranging from recipes that were primarily made from calcium carbonate to recipes that were primarily made from compost. For each recipe, we fabricated a small pot with an extruder to examine how well the recipe held three-dimensional form and how easy the material was to work with. Our optimal recipe is mostly made from compost, can be extruded with minimal effort, and easily holds three-dimensional forms. Despite finding an optimal recipe, we realized that each batch of ReClaym came out slightly different due to our ever-changing compost. Thus, we were inspired to develop a corresponding practice for working with ReClaym's inconsistencies that we call intimate making, which utilizes familiar techniques to foster maker-material communication that leads to a material understanding. Intimate making specifically employs familiar hands-on fabrication techniques like sculpting, molding, and extruding to foster direct communication between the maker and the material through the sense of touch. The constant physical communication with ReClaym led to an embodied knowledge and eventually to a deep understanding of the material. By fully understanding ReClaym's capabilities and limitations, we learned to collaboratively work with ReClaym rather than forcing ReClaym into predetermined forms. Thus, intimate making often results in imperfect yet meaningful artifacts that reflect both the agency of the ReClaym and our personal handiwork. Through intimate making, we gained confidence working with ReClaym, which spurred an exploration of how ReClaym could be further customized and utilized. We first took inspiration from ReClaym's natural, non-sterile nature, using its origin as compost, which contains many living microbes, to create a living sculpture. This then led us to devising a method to sterilize ReClaym by baking it in the oven, effectively killing all the microbes. We tested our baking method by performing a microbial growth test. The Petri dish inoculated with the unbaked ReClaym resulted in the growth of microbes, while the baked ReClaym resulted in no microbial growth, proving its sterility. This then led us to the creation of food-safe tableware like bowls and plates that highlight the circular aspect of eating a meal off of food waste that has been given a second life, and then composting the tableware, once done eating, to create more ReClaym items. We then explored adding conductive properties to ReClaym by coating still drying ReClaym with activated carbon and graphite powders. We measured the resistance of each of these conductive ReClaym tiles, finding that activated carbon was more conductive. We then used our activated carbon tiles as capacitive touch sensors that we transformed into an instrument. Similarly, we coated still drying ReClaym tiles with a thermochromic pigment that changes color based on temperature, going from dark blue when cold to light blue when hot, a photochromic pigment that changes color based on UV light exposure, going from light pink when not exposed to dark pink when exposed, and lastly, a photoluminescent pigment that we use to create a collection of garden sculptures that charge throughout the day with UV light and then luminesce in the dark when the sun goes down. We also colored ReClaym by adding plain food dye, a biodegradable glaze that we formulated from food dye, cornstarch, sodium alginate, and water, and a cosmetic grade biodegradable glitter gel. We used color to create game applications such as custom figurines for a Dungeons and Dragons sorcerer character and Carcassonne tiles. Lastly, we explored adding textures to ReClaym by imprinting leaves, the tongs of a fork, and the edge of a spoon. We took this exploration a step further by creating a memory keepsake for a puppy in which we took an imprint of its paw. Once our ReClaym artifacts were no longer needed or wanted, we disposed of them circularly by either composting them with our food waste to create new batches of ReClaym, or by letting them biodegrade in the environment, in which case the compost within ReClaym actively replenishes nutrients in the soil and encourages the growth of new plants that we can then harvest for food and effectively restart the ReClaym life cycle. In conclusion, we developed ReClaym, a sustainable and personal clay-like biomaterial made from our composted food waste, and a corresponding practice for collaboratively working with ReClaym called intimate making. Thank you all for listening. I want to thank my co-authors, Netta, Ofer, and Mirela, Alistar, and I am now happy to take questions.